Hey guys, welcome back to my channel. So as I told you, this is the step we have to follow to design the VRF project. So in this video I'm going to follow the step by step procedure. Each step we have to follow and I will design this project. So you can see this is already designed here, so I will do the designing here again to show you just for the sample. So the first step is heat load calculation. So we have to do the heat load calculation using HAP software. So let me open this HAP software. Okay, so just wait. Okay, and here you have to cancel all these things, cancel, and then this is your HAP software. So you have to, what you will do, you have to go to this untitled, right click, go to the property, and here you have to provide the project name first. So the project name is school project. Let us assume, let's say school project, simple VRF system, VRF system. Okay, and just click OK, remaining just leave it as it is, and then you have to go to the project. Then go to this views and preferences, then you have to select the metric or English, whatever it is. Go to the, here you can go to this, there are two tabs you can found, the general and project. So go to the project and select here the ventilation standard, which is I'm going to select SRS 62.1 2007. Okay, and then go to the general. Here in the general you have to tick all these tools and select the metric system and or English system, whatever it is, as per your convenient. You can select, you can change it later as well. So I'm going to select the English system and click OK. Now next is go to the weather properties. So I'm going to select this weather and double click here, and here I'm going to design the VRF system for India. So I'm going to select the Asia Pacific here, and location is India, and I'm going to do for designing for the New Delhi. Okay, and just select this, and here you can see the software is showing all these parameters, which is automatic. Just you have to select these three parameter and then go, do not don't do anything, just click OK. Next is your U value. So go to this project library, and here you can select wall and double click here, and wall, default wall assembly U value for the wall. You can say here wall, external wall, external wall. Okay, and I will show you one U value sheet here. You may use this just for the sample, because U value is given by the architectural team. So for time being I'm going to use this value. So here for the external wall the U value is 0.89. so I'm going to use this layer here in this project. So here the layer number 1, the 1 inch inside surface resistance, 0.5 inch plaster, 0.5 inch plaster inside and outside is already here given in the software. So 0.5 inch plaster cement, here is the inside and outside. So here you can say 0.5 inch, 0.5 inch plaster, you can say plaster, and here the thickness is 0.5 inch, 0.5 inch, and next is density of the plaster is 116.250. so density here you can see density 116.25. just double check, 116.25, and R is 0.1. R value is 0.1. Next layer is 8-inch concrete block. So you can say here concrete block 8-inch concrete block. So here you can enter the 8. Density of concrete block is 84.37. 84.37 here, and R value is 10.12. 10.12. Next layer is 0.5 inch plaster cement again. So here 0.5 inch, just copy this, paste it here, 0.5 inch plaster, 0.5, and here is 116.3 or 116.25, and R value is 0.1. 0.1, and here you have to delete this, remove this layer, and you can see here 0.088 the U value. So here you can see 0.089, the approximate same. So it's okay. Now you have to click this and go to the roof layer. So roof U value, so double click here, and roof, you can say roof, and here you have to follow the same steps. The sandstone 125. So first layer is sandstone. The density of the sandstone and thickness is 2 inch, and the density is 125. So here you can say 2, density is 125, and the R value, which is thermal resistivity, so R value is, you can say here 0.231. 0.231. Okay, next layer is your next layer is 0.5 inch plaster cement. So 0.5 inch plaster cement. So here you can say 0.5 inch plaster cement. Here 0.5, density of the plaster is 116.25. 116.25, and the R value is 0.2. So here the R value is 0.2. Okay, next layer is here extruded polyester insulation. So extruded polyester insulation 2 inch, density is 2. Extruded polyester insulation, thickness is 2 inch, and density is also 2, and R value is 2, and thickness in R value is 9.589. 9.589. Okay, next you have to add the layer here. Remove insert layer, remove this, and you have to add here insert layer, which is lightweight concrete, so thickness is 2 inch and 100 is the density. So you can say here lightweight concrete, thickness is 2 inch and density is 100 and R value you can check here 0.34, 0.344. okay. Next layer you have to add one more layer. You can see here the reinforced concrete 150 and thickness is 8 inch. So you have to add here reinforced concrete, thickness is 8 inch, density is 150 and R value is 0.624, 0.624. okay. And next and last final layer is the 0.5 inch plaster cement again. So you have to just copy paste 0.5, density is 116.3, R value is 0.2. okay. So you can see here 0.082, the overall U value is 0.082. you can just match it here 0.087, so which is approximate same. So just click OK. So this two is over. Now you have to click your project here, click it, and then go to this space, or you have to go to the schedule. So let me create the schedule. So here first schedule is people, select profile 1 and you have to assign this, click OK, double click, duplicate, then lighting schedule, lighting profile 1, assign all this, click profile 1, click OK. Next schedule is equipment schedule, select profile 1, assign the, click OK. Next and last schedule is thermostat. So TS, just select this fan thermostat, then profile 1, assign, click OK. You can save this. Okay, again. You have to create the spaces. So here you can go to this project and create the space. So first one in the classroom one. So go to this project software and click on a space, double click here, and then you have to create the space which is classroom 01. Floor area, so floor area you have to get from this drawing. So just check the area, AA, type AA, add area, and then you have to select like this here, like this. Okay, and click here, and then you can see the floor area which is 876 square feet. So floor area 876 square feet here, 876, and height is let's say 9 feet for example, and building weight is medium, so just keep as it is, and out spaces is classroom. So here is the classroom, which is age 9 plus. So you have to select this for the fresh air. Then go to the internal. So internal you can select here the lighting fixtures. So reset unvented, it says vented, and wattage is 1 watt per square feet or 1.4 watt per square feet. Select the schedule, which is lighting equipment people lighting schedule, and here is the task lighting is not applicable, so go to the electrical, and here in the electrical 1.2 watt per square feet. Load equipment, select the equipment, and number of people. So here you can check the number of people for the classroom. So go to this folder, and here you can open this parameter, which is 62.1 2007. So I have already calculated. Just to save the time, I will let me open this. The number of people is here 28 people for 800 square feet. So just go here, enter 28. Office work or seated at rest. They are seated at rest. Seated at rest. Okay. Then you have to select here people, and next is wall and window. So you have to select the exposure. So here you can say, let's say here north side with east and west. So here let's say this is your orientation. Okay, here is your north. Let's say this is north. Okay, and this downside is south, and this is the east and west. Okay, so here the exposure is north, and this is the partition. So let us check this length. Exposed wall. So here is the exposed wall, which is 27 feet. So the north exposure, just select here north, and wall gross area. So let's say the length is 27 and height is 9. So 243 square feet. So here is 243. Window quantity is 1, and here you can select the window 1. Here wall is external and window create, you have to create the window. Let's say window 1, which is 5 feet by 3 feet, let's say. Just click OK. And the next is there is no exposure. Go to the roof and skylight and select here horizontal roof, and the roof area, gross area is 876. I think this is wrong here. 876 square feet. 876 square feet. Here you can also see 800 square feet. So approximate 876. Okay, so here is your roof and skylight, 876 square feet. Here you can select roof, then infiltration just leave as it is. Go to the floor, and your floor is on grade, so just select floor is on grade. Floor area is 876 square feet. U value is 0.1. Okay, then go to the partition. So here is the wall partition is applicable. So let's say your wall here is DLI. This is your partition for the exposed wall. Here is just check 28 feet. 28 feet, 28 by 9, which is 252. So 252 square feet, 252. The value is, let's say, 0.5 because it is given by the civil people. And ambient temperature. Ambient temperature is you have to check here the ambient temperature in the weather. Here you can see the for Delhi 107 and 107 degree Fahrenheit. Go to the space here, double click. Ambient temperature is ambient at maximum 107 and unconditioned space maximum temperature is less than 5 degree, the ambient, so which will be 102. Unconditioned range, so you know the formula for the range is unconditioned space maximum minus unconditioned space minimum. So the daily range you have to select, let me open one software here, which is all here. I will show you climatic software. I said climatic data here. Let me open this, and here cooling, and I am going to select here India, all region, and here is Delhi. So you can see the daily range here. The ambient temperature 107 and daily range average annual maximum mean daily range is 22. So unconditioned space maximum minus unconditioned space maximum minimum. So here daily range is 22. So 22 minus unconditioned space maximum temperature. So unconditioned space maximum temperature is 102. So 102 minus 22, 102 minus 22 is the 80. So unconditioned space minimum temperature is 80. And here is the ambient, so which is less than more than 5, so 85. Okay, so I hope it is clear for you. So let us click OK. So the classroom 1 is over. Now next is your ground floor computer room. So computer room is go to computer room here, double click and duplicate this, and here you can edit computer room. Here you can check the area. Here you can see 863 square feet. The area for the computer room is 863. So 863 square feet and height is 9 feet. And here is the computer room, which is nothing but the classroom only. Okay, so let us skip it. And these are the same, and number of people you can check from this here, the 21. So here you can change the 21 and then go to the wall. So north exposure is there, you have to check north and east exposure. So DLI, just check the length. Six feet. So here 26, let's say here 26 by 9, which is 243. So 243, and window is 1, which is 1, and east exposure is also there. So just check here length of the east exposed wall, which is 32 feet. Go to the software, and here you can select 32 by 9, 288. So let's say here 288, and window is 1. create window 2. Let's check the length of the window. It's 24 feet. So width is 24 feet, and height is 5 feet, let's say, and click OK. So next is your roof and skylight. So roof and skylight 863, horizontal roof 863, no infiltration. Then here is 863 floor, and then partition, so there is no partition here, make it 0. Okay, and then click OK. So there is no partition. Next is your classroom 3 and 4, 2 and 3. So just here click, duplicate classroom 2, and area. So calculate the area. I want to save the time, so here is the classroom 2. The area is 600 square feet. So just enter here 600 square feet. Education classroom, then internal is, you have to change here only the number of people. So number of people is 21. Exposure is south. Here just check here length of the wall, which is 23. So 23 by 9, 207. Here is 207 square feet. Window is 1, let's say window 1. Then roof is, you have to change the roof 600. Here you can change 600. Go to the floor is on grade and partition. So let us check is there is any partition or no. So here this wall is your partition, because pump room and storeroom we are not going to do the air conditioning here. So this will be your partition, which is 32 feet. So there will be one wall partition, which is 32 by 9, 288, and then click OK. Next is your classroom 3. So just duplicate this classroom 3, and area for this classroom is, here you can see 600 square feet. Number of people is 21. 600 square feet. Then go to the internal. Here is 21 people. Then windows and walls. So there will be south and east exposure. South and east. So south will be same and east will be, let us check here the length, which is 32. So 32 by 9, 288. Window 1, which is window number 2. Okay, and then roof and skylight. So roof and skylight, horizontal roof, slab floor on grade, then partition. So there will be no partition, which is 0. Then click OK. Now next and final step is the lobby. So you have to create the lobby. Select the area. Here you can select anyone here. Let's say this one. Here is your lobby. Lobby and area for the lobby is, you can check from this Excel sheet, which is 700 square feet. So just enter here 700 square feet, and here you can select the lobby, which is corridor. Then partition is east partition. There is you can select here east. east partition, and just check here is the east exposure, sorry, here is the east exposure, 14 feet, 14 by 9, which is 126. Here is 126, and there will be west as well. So let me check this also. Here you can see this is the not exposure, this is the partition. So this will be counted in partition, which is 8 feet. Okay, so there will be one door, there is no window, door is 1, so let's say D1. Okay, so here is window is 0 and door is 1. Okay, then roof and skylight. So horizontal roof and 700 square feet, so you have to update here. 700, infiltration is 0, floor area is 700, partition is wall, so which is 8 into 9, 72. Click OK. Now you have to save this. So this is your space is ready. Now next is go to the system and create the system here. So here system name is ground floor VRV system. Okay, equipment type, so you have to select the equipment type which is comes under terminal unit, and here you can select the air system type is variable refrigerant flow, number of zone is 1, and next is zone. Go to the zone component, and here you have to add all the spaces into the zone. So let us select and add it. Go to the thermostats, and here you no need to change anything, just select here thermostats. Then common data, so common data you keep the design supply temperature is 54 degree Fahrenheit, coil bypass factor 10%. Okay, and if you want the heating you have to select, otherwise leave it. Terminal unit, here you can see, here no need to change anything. Then go to the sizing, which is here the safety factor is 10% sensible and 10% latent. Then click OK. So your system is ready. Now the time is to create the report. So just click here and you can generate the report. So let us generate this. So this is your report. So let me save this. Ground floor VRV system load report, and let me save this on the desktop, which is here VRF project. Click on save, then go to this here you can see the ground floor load report. Okay, so here you can see how to read this. This is your you can see the air system name. This is outdoor air system sizing summary. This is the system sizing summary. So here is the air system information, which is air system name. I will show you how to read this in the next how to read this report in the next video. So please be with me and keep watching my videos. So this is the over for this the load calculation. So next step will be calculate the fresh air calculation. So in the next video I will show you guys how to do the fresh air calculation. So please be with me and keep watching my video. So thank you for watching my video. Thank you. Bye bye.